back and watch what we're talking about during this class, you will be able to do that on your own time. All right, let's see. Where are we going here? This one is what we're going to. Alrighty. So last week we were talking about things like some basic properties of matter, like states of matter and the phase changes is kind of what we started off with. And then we talked about like differentiating between what are some physical properties of matter, what are some chemical properties, what happens when matter goes through a physical change, what happens when it goes through a chemical change, and we get some totally new matter. So we've been talking about all like these sort of different properties and structures and things surrounding the matter. Today, we're actually going to go even further down the rabbit hole and even smaller in the size of our scope. And instead of talking about how all these little particles together are creating our matter, we are going to talk about what are those little particles themselves. What are those tiny little molecules that make up all of the matter in the universe? So today we're going to talk about them. We're going to kind of talk about what their structure is and what are the different parts that make up these tiny, tiny molecules. Alrighty here. So those tiny, tiny little particles that make up all of the matter in the universe, everywhere, everything is made out of tiny structures called atoms. So atoms are normally drawn with like this kind of central area, and then these little rings going around them, which is sort of how they're constructed, and we'll talk about that a little bit more later today. And so today we're going to talk about the atom. We're going to talk about kind of what it is, what the structure of an atom is, because atoms are made up of smaller parts as well. And a little bit about the periodic table, which is sort of this big diagram of all of the different atoms that have been discovered by scientists so far. So the periodic table looks something kind of like this. If you've ever been in like a high school science classroom or chemistry classroom, you've probably seen it before. It's this big wide table with all of these little individual boxes in it. And these boxes are all filled in with a couple different numbers and some symbols. And so today we're not just going to talk about what are the structures of the atoms themselves, but how can we figure out some clues about how the atoms are structured based on the information in their little periodic table boxes that are on this big chart. So you're going to learn about a little bit more about how to read all of the information contained in this one big table that scientists have put together. All right, so atoms. Atoms are the smallest individual units of matter. They are basically the building blocks for everything else in the universe. All matter in the universe is made up of atoms. So the atoms themselves are kind of grouped into three smaller pieces. So there's these three little pieces, these three little what are called subatomic or like smaller than atom particles that go into making up an atom. They are protons, neutrons, and electrons. Protons, neutrons, electrons, three of them. So the protons and neutrons are what are kind of together in that middle section. And then the electrons are zooming around on the outside. So you can never really see this because they're so tiny. And in pictures, they have to be standing still. But these electrons are actually always moving. They're constantly moving around the outside of the atom. So today we're going to talk about what is a proton, a neutron, and an electron, and how do we figure out how many of them are in each atom? Because each individual atom has a different count of the protons, neutrons, and electrons that are in there. So let's start off by talking about kind of the two main kind of sections of the nucleus of the atom. So the inside part where the protons and the neutrons are, this is called the nucleus. So the nucleus is this kind of ball of all these little particles that are all clumped really closely together in sort of the middle of the atoms. So the protons and the neutrons are clumped together here in the nucleus, and then the electrons are kind of zooming around the outside of the nucleus. So the nucleus right in the center here, most of the atom's mass, like 99.99% of the weight of the atom comes from the nucleus. And we'll talk about why that's important in just a couple slides here. So nucleus is the middle, and then electrons are zooming around the outside.
Zooming around. Hey, nucleus.
Hmm.
Oh my God.
What happened?
All right. So nucleus, middle, electrons, outside. So the nucleus is made out of two different particles altogether. The protons, which in this picture are like the little red balls, I think. Yeah. So the protons are inside of the nucleus, and they have a positive charge. So all of the little particles that we're talking about, the electrons, the neutrons, and the protons, all have some sort of electrical charge, and the protons have a positive charge. So one proton means one positive charge in that atom. So protons inside the nucleus in the middle of our atom here, and they are positives, they are pluses. The other thing that we've got going on in the nucleus are our neutrons. Oh, one more thing. The easy way to remember the charge of protons is just remember P. Protons are positive. P, P. Positive protons. Positives for protons. So besides the protons, also in the nucleus, we have the neutrons. So the neutrons are, in this picture, they're these little blue balls. And so again, the neutrons and the protons all together make up the nucleus. Now, you might be tempted to think that neutrons have an N, so that might mean that they're a negative charge. Don't think that. That's wrong. Instead, remember that neutrons are neutral. So neutrons do not have a charge. It's like a zero charge. It's not positive. It's not negative. It's neutral. So neutrons are neutral. They do not have a electronic charge to them. So together, the neutrons and the protons make up the atomic mass. So if you know how many protons and how many neutrons that you have, you can put those amounts together and it'll tell you the atomic mass of the atom, essentially how heavy the atom is. Some atoms are really light. They only have a couple protons and neutrons in the nucleus. Some atoms are really heavy. They have a lot of protons and neutrons in the nucleus. So neutrons are neutral, and they're hanging out with protons in the nucleus where they make up the mass of the atom. So the weight of the atom essentially is just the protons and neutrons together. All right, and so finally, the third major particle type that we're going to go over are the electrons. So electrons are not in the nucleus. They're not hanging out in here. Instead, they're floating around the outside of the nucleus. So they're zooming around all around this kind of outer area out here. And electrons are negatively charged. So they have like a minus charge or a negative charge. So electricity, things that we use to like turn on the lights and run our computers, come from moving a whole bunch of electrons around. And so all of those little negative charges together are what gives us electricity. So I kind of think about it as if you get an electric shock or you get like electrocuted, that's going to be not a fun time. That's going to be a negative time. So negative for electrons. Electrons are these little minus charges that are floating around outside of the nucleus. So we've got our positive protons and our neutral neutrons clumped together in the nucleus here. And then we have our negative electrons zooming around the outside. All right. Any questions so far about our atoms or the three particles that we've talked about? All righty. Does not sound like it. Sounds like everybody's doing okay with these things so far. So the next thing that we are going to look into is a little bit about the information that comes on that periodic table that I was talking about a little bit earlier. So like I was showing you guys, every single element out of the 112 or 13 or 14 or however many that they've discovered so far, every single atom gives its own little box on the periodic table. And for the most part, the boxes look like this. You have a kind of a symbol or abbreviation in the middle. You have a word written out. And then you have a number on the top. And then a bigger number on the bottom. So the symbol and the word are just the name of an atom. So in this case, this atom is krypton, and its chemical symbol is Kr. For the most part, the chemical symbol is pretty similar to the name of the atom. So like carbon, the symbol is just a C. Oxygen, the symbol is an O. Tin, the symbol is a Ti. What other symbol? Sulfur is just an S. Krypton is a Kr. Neon is Ne. But some atoms, if you look on the periodic table, they have kind of weird symbols compared to their names. Like gold has the symbol of Au. Iron, the symbol is Fe. So it doesn't always match up directly. Usually it has to do with like there is some old Latin name for the element, and so they just use that for the symbol. But regardless, we have our name of the atom and kind of the chemical symbol, a little representative thing for it. Question.
Do we need to remember this one, the formula?
What was that?
Do I need to remember this one?
So you don't need to remember this atom in particular, but just remember that this part is the name of the atom, and this part is the symbol for the atom.
Oh, okay. Yes.
All right, awesome. Good question. So those are the two letter parts, and then we also have two numbers. The number on top is called the atomic number, and the number on the bottom is the atomic weight or the atomic mass, essentially how heavy the atom is. So we're going to start off talking about the atomic number, this smaller number on top. So the cool thing about the atomic number is that it tells us the number of protons that are in this atom. So every single atom in the periodic table has a different atomic number because every atom has a different number of protons. So only krypton has 36 protons. No other atom have that number. So whatever this atomic number is right here, that is the number of protons in the nucleus of that atom. So krypton has 36 protons. Helium has an atomic number of 2, so it has 2 protons. Oxygen has an atomic number of 8, so it has 8 protons, and so on and so forth. So however many, whatever our atomic number is, that is our proton number right there. So that's the first important thing to remember about these numbers, is that if you want to know the number of protons, you just look at the atomic number. That one, pretty simple and straightforward. The other number, the one down here on the bottom, is the atomic mass, also sometimes referred to as the atomic weight. It's an approximate mass of one atom of that element. And it's not a measurement of weight in terms of how we normally measure weight, in terms of things like grams or pounds or ounces, because atoms are super duper duper incredibly small, teeny tiny, right? If you wanted to measure like how many pounds an atom was, it would be something like 0.00000000000000000000000000000000019 pounds. Obviously, nobody wants to write out a 0 17 times whenever they want to write the weight of an atom. But atoms do have weight. We can compare them to each other because some atoms are smaller and lighter, and some atoms are bigger and heavier. So instead, scientists came up with the measurement of AMUs, atomic mass units. So for example, krypton is approximately 83.8 AMUs. So it's kind of like a medium-sized atom, I would say. There's some atoms that are like 6 or 8 or 10 AMUs. There's some atoms that are like 215 AMUs. But whatever the weight, that is what that number down here on the bottom of the periodic table box is showing us, is how heavy is this atom. So the handy dandy thing about our atomic weight is that we can use it to find out some more information about the number of particles in our atom. So like I said, with the atomic number, it directly tells us the number of protons. Neutrons, on the other hand, are a little bit trickier, a teeny tiny bit trickier. And you'll have to do some very, very basic, simple math in order to figure them out. And that math looks something like this. So we know our protons are the atomic number. That's pretty straightforward. Whatever the atomic number is, that's how many protons it is. And if you remember from a little bit earlier, a couple slides ago, I mentioned that the atomic weight of the atom is the protons and neutrons combined together. So if you take your protons and you take your neutrons, you add them together and you get the atomic weight. So that means if we had our atomic weight and we minus our protons, which are the atomic number, we can figure out how many neutrons are in our atom. So if you do the atomic weight minus the atomic number, that will be equal to the number of neutrons. Because we have the weight, which is protons and neutrons together. We take away the number of protons, which is the atomic number, and then we're left over with the neutrons, right? If we have protons and neutrons together, if we take away the protons, then we'll just have the neutrons.
So we have to subtract the weight and the number to get your neutrons. Okay.
Exactly. So the weight, remember, is that bigger number on the bottom, and the atomic number is the smaller number up on the top. So if we went back to our krypton example, it would look something like this. We know that our atomic number is 36, and technically our atomic weight is 83.80. For calculating your neutrons, since if you don't want to deal with all those decimals, I would definitely recommend just rounding it to the nearest whole number is totally okay. Just because it makes it a little bit easier to deal with. So the atomic weight we can say is about 84 for a krypton. So our protons are 36. Pretty simple. We have 36 protons in krypton because the atomic number is 36. For neutrons, we have to do the mass minus the number. We said the atomic mass is about 84. 83.8 is close enough to 84 to where we can just round it. And the atomic number is 36. So 84 minus 36 will give us 48 neutrons. So that is how you calculate the number of neutrons. You take the weight, you subtract the protons, and that will give you the number of neutrons. Make sure to remember that, because a lot of times I see people forget that after a couple days and they assume that the atomic weight is the exact same as the number of neutrons. Not the case. The weight minus the number is the neutrons. So you have to do a little bit of subtraction in order to calculate your neutrons. All right, so 84 is the weight, 36 is the protons. Weight minus protons gives us neutrons, 48 neutrons in krypton. And again, we could do that the other way around, right? If we wanted to double check that the atomic weight was right. So if we know that we have 36 protons and 48 neutrons, if we combine the 36 and the 48 together, we should get 84, which is about the correct atomic weight. All right, so if you ever write down the number of neutrons and you didn't do any subtracting, then you probably did something wrong along the way. So make sure that whenever you're calculating neutrons, you do this very simple subtraction problem. Weight minus number.
So weight minus protons would always give you neutrons. Okay.
Exactly. And the protons, you just look at the little number right here. So simple to find protons, and then only slightly less simple to find neutrons. Precisely. All right, any other questions about how you figure out the number of neutrons in an atom? All right. So we figured out our proton number. And we figured out our neutron number. So the one thing that we have left to calculate is our electron number. So in this class, we're only going to be dealing with what are called neutral atoms. That means atoms that don't have an overall positive or negative charge. They have a neutral overall charge. If you take later chemistry classes, you might start hearing about ions that are like positively charged or negatively charged. But in this class, in IPC, we're just going to focus on neutral atoms. And the handy thing about that is that neutral atoms have an equal number of protons and electrons. So because it has an overall neutral charge, remember that our protons are positively charged and our electrons are negatively charged. So this means that if we want a neutral atom, we have to balance the number of protons and electrons. They have to be the same, so those positives and negatives can equal each other out. So what this means is that a neutral atom always has the same number of protons and electrons. So however many protons that we have in our atoms, we're going to have the same number of electrons. So for our most basic atom down here, hydrogen, hydrogen is the very first element on the periodic table. It's way up in the top left corner. It has an atomic number of 1, which means that hydrogen has 1 proton. So if hydrogen has 1 proton, that means that it has to have 1 electron. So 1 proton and 1 electron in hydrogen, because the protons and the electrons have to be equal. They have to be the same. So if we go back to our krypton example over here, thinking about the new electron rule that we just learned, how many electrons does krypton have?
$36.
Precisely, Fernando. And how did you know that krypton has 36 electrons?
That's how many protons it has.
Exactly. Fernando has nailed it right here. So krypton has 36 protons, which means that it also has to have 36 electrons. Bingo, bango, bongo.
So it's always going to be the atomic number, so it doesn't matter as long as it's so if it was like 15 for the atomic number, it'd be the 15 electrons, right? Okay.
Exactly.
So the atomic.
Yeah, precisely. At least for this class, like I said, there are cases where the proton and electron number gets different. But in this class, we're only looking at neutral atoms, and neutral atoms always have the same number of protons and electrons. And since the atomic number tells us how many protons we have, it also tells us how many electrons that we have. So for another example right here, here we have the atom carbon. It has a symbol of C, it has a weight of 12, and it has an atomic number of 6. Carbon is element number 6. So, how many electrons are in carbon?
6.
Yeah, exactly. And how did you know that electron, or that carbon has 6 electrons?
In the top, on the nose.
Exactly. The top number, the atomic number is 6, which means that carbon has 6 electrons and 6 protons. So the atomic number is the same as the number of protons and the same as the number of electrons. So that's protons and electrons, but what about neutrons? How many neutrons are in carbon?
12.01.
So not quite. Remember that 12 is the weight of carbon.
It would be 18.
Do in order to find the neutrons.
You would subtract 12 minus 6.
Oh.
6.
Yeah.
Because you're rounding 12.1, so you just leave it at 12.
Yeah.
So 12 minus 6.
Exactly. So you just say that this is about 12 for the atomic weight. And then 12 minus 6 is 6 neutrons. So yeah, that's the tricky thing to remember about neutrons, is that it's not just the weight. You have to do the weight minus the atomic number. So carbon is a little bit smaller atom, and in a lot of cases with the smaller atoms, the protons, electrons, and neutrons all just kind of happen to work out as the same. As you get bigger and bigger with your atoms, Like with krypton here, they become a little bit different. But carbon is a pretty small atom. So carbon has 6 protons because it has an atomic number of 6. Carbon has 6 neutrons because we do 12 minus 6 is equal to 6 neutrons. And carbon has 6 electrons because the electrons and the protons have to balance out. And we already figured out that there are 6 protons in carbon. So protons and electrons are this top atomic number. Neutrons are the weight minus the number. All right, did that help you figure out things a little bit, Dwee?
Yes, it is.
All right, excellent. So anybody have any other questions about protons, neutrons, electrons, atomic numbers, atomic weights, anything that we've covered so far today?
No.
All righty. So the assignment that I gave for you guys today is all about dealing with these proton, neutron, electron questions. So as always, you are free to choose to do either the Google Docs version or the Google Form version, whichever you prefer. And in each version, you have a series of elements that I'm showing you. And I want you to tell me for each one how many protons, how many neutrons, and how many electrons are in each element. So we've got fluorine, scandium, platinum, radon, uranium, and borium. And so the one thing that I did want to mention about if you do the Google Form version, there are 3 things that you're figuring out about each element, but there's only one line. And so when you want to write down your answers, make sure that it's set up something like, I'm just going to make up some numbers. 1 proton, 1 neutron, 1. And hopefully I can spell proton right. So make sure that for each answer for these, you have all 3 different types of particle. On the Google Doc version, it's a little bit easier to fill in just because it already has the name of the particle written out for you. You just have to go in and fill in right next to each one and say, all right, I think that fluorine has 1 proton and 1 neutron and 1 electron. So again, you don't have to do both versions. You can choose which version that you'd rather do more. Just remember that if you do the Google Form version to include all 3 different particles in each of your answers. The other thing and the other little tip that I'll give to you guys for working on the homework for today, not that I think that you guys would do this because you're all here, so you're all good students anyways, but in the past I've had some issues with people that try to just like Google how many electrons does this atom have and then put that in for the answer. And while on some of these it worked out okay, some of them, the answer that first comes up on Google is actually not the correct answer. So for a while I kept wondering, like, man, so many people are getting like this particular question wrong in the same way. Why is that? And then I figured out like, oh, if you Google how many electrons are in this, it'll give you an answer that's different than what you'd figure out from the homework. Like I said, I don't think any of you guys would do that because you're all obviously good students. Just remember to work on this on your own. Obviously, go back to the notes to help you out if you need some. But don't resort to Googling because you might end up getting and writing in the wrong answer and losing a couple points that you did not need to. So that is the assignment going up today. The one going up for your Wednesday daily assignment is a little bit more simple and straightforward. It's kind of just a review of some of the major things that we talked about today. So it has some information about protons, neutrons, and electrons. And then it gives you this little box of the atom helium and asks some basic questions about the names, the symbols, the atomic number, the mass, and then the proton and neutrons in helium, and protons and electrons in helium, and the neutrons in helium. So like I said, just make sure to read through the questions carefully. The most common mistake people make with this one is that they don't read this question all the way, because this is actually a two-part question. I want to know protons and electrons, which if you actually read the question, it says protons and electrons. Just a good reminder there to always make sure to read the question before jumping in and putting down what you think is the final correct answer.
Is that our homework but that's on Google Forms, right?
Mm-hmm. So this will be the Wednesday assignment. So this will be posted tomorrow.
Oh, okay. I was like, so it's not even posted yet. I was like,
No.
I don't see that. Yeah, because the one
you guys are in class today, I like to give you a little sneak peek.
Yeah, okay, because the one I was looking at right now was our homework, and that only had 3.
Mm-hmm.
Yeah.
So the one that I was showing you a little bit ago that asked you to calculate the protons, neutrons, electrons for everything, that is today's homework. And then tomorrow's assignment will be that little review with the helium atom in it.
Oh, okay, gotcha.
Good call. And then when we come back together on
And this class is recorded, right? So we could go back.
Exactly. Yep.
I'm sorry. The class is going to be recorded and posted.
Yes. Yeah. So I'll post.
Okay, just asking because I think I missed some parts because I'm helping my kid with her homework as well.
Gotcha. Yep. This is 100% recorded, so I'll make sure to post the recording pretty much a couple minutes after we finish up with class here today. All right. So anybody have any other questions about the notes from today or the homework coming up either today or tomorrow?
No.
No, sir. No questions.
No questions here.